So to start off with, we're just going to look at this idea of locus, however you want to say it. Okay? And all it is that. Okay? The collection of all points whose location is determined by some stated law. And of course, those laws we usually see as, in an algebraic sense, y equals x squared, y equals x cubed, and so on. But it could also be written in a geometric sense, where it starts talking about distances and things like that. So something like this. What's the locus of the point which is always 4 units away from the origin? So all the points that are 4 units away from the origin. It would, of course, be circle. So sometimes you can recognise it straight away, and that's fine. You recognise it straight away, write down the equation. But if you don't, and you need to think about it, you go, okay, 4 points, I could have the point 0, 4. I could have the point 4, 0. Or actually the other way around. Negative 4, 0. I could have negative 4. And then after a while you start going, I think I know what this shape is. There we go, a circle. But even then, if you're looking at it and going, what's the equation of that shape? We can do it using our coordinate geometry. We could just give one of those points the random coordinates x, y. And the condition for this problem is that that point is always 4 units away from the origin. So in other words, using the distance formula, the distance from x, y to 0, 0 is 4. Now if I was to square both sides, tie it up, sure enough we get our equation of the circle. X squared plus y squared equals 16. So you can usually go back to the algebraic techniques to work out the final answer if you're unsure. So a point moves, it's always 5 units away from the y-axis. What would that be? Y equals 5. Let's have a look. Okay, here's the number plane. There's my random point. My random point. Your random point. We're saying the distance to the y-axis, so we can give that point coordinates 0, y. Sub it into our distance formula. And we get x squared is 25 plus or minus. It never actually said to the left or to the right. And yes, actually it's x, not y, but I think we've realised that one. But the main point there is actually plus or minus, because it could be 5 units on the left-hand side as well. So doing it algebraically, it picks up that plus or minus because we've got x squared is 25. 3 units away from the line y equals x plus 1. This is not as straightforward because it's really tempting to say that that's the line y equals x plus 4. Now, it seems logical. The reality is it's not that. So there's our line y equals x plus 1. There's our random point. Remember, we're talking about distance from a point to a line. It's the perpendicular distance. So in fact, it's the perpendicular distance that's going to be 3. If it was y equals x plus 1, it would be the vertical distance would be 3 units away. So it's got to be something else. There's my perpendicular distance formula using the random points x, y. Multiply both sides by root 2. Absolute value equation to solve. So there's our 2 possibilities. One could be x minus y plus 1 minus 3 root 2. That would be below the line. And there's the other one. X minus y plus 1 plus 3 root 2 would be the one above the line. So sometimes, as I say, it's not as immediately obvious as you might think. Point moves, its distance from the x-axis is always 5 times as great as its distance from the y-axis. So distance from the x-axis is 5 times distance from the y-axis. Gut feeling on this one would be 5. The other logical possibility, I suppose, would be 1/5, depending on which one it's closer to. So they probably would be the 2 answers I would expect. One, of course, is correct. One, of course, is incorrect. Let's see which one is which. So distance to the x-axis, so I'll call that the point x0. Distance to the y-axis, call that 0y. And we're saying the distance to the x-axis is 5 times the distance to the y-axis. Square both sides, and sure enough, yep, it's plus or minus 5x. You can have 2 possibilities for that one. point moves so that its distance from the point 1, 2 is the same as its distance from the point 5, negative 4. Now, this one really is a bit difficult to just look at and get the answer. Different ways of thinking about it, I suppose. Here's our number plane. There's the 2 points. What I do know is the midpoint must be included. So Pxy could be any random point, but I know the midpoint would be one of them because the distance is going to be the same. I also know that this will end up being the perpendicular bisector of that blue line there. So I could do it using that idea, perpendicular bisector. So the slope, minus 3 on 2, but it's perpendicular. So the one I want is 2/3. Midpoint is 3, negative 1. I can use my point slope formula then to find the actual equation. Of course, the other way I could have thought about it was, again, I could have just said the distances are the same from my random point. So I could have equated those two distance formulas. Square both sides, expand out, x squareds cancel, y squareds cancel, and we end up with 8x minus 12y minus 36. But of course, all of that is divisible by 4, and we do get the same answer. So I suppose one, again, is an algebraic way of thinking about it. One's a geometric way of thinking about it. Oh, geez. 9A we're going to do. Oh, will the questions ever stop? Oh, no, they just keep coming. Oh, there we go. We'll have that.